Welcome to YQ Academy Threads Java Interview Questions and Answers. 1. List Java API that support multi-threading. 1. Java.lang.thread: the thread class is the core class for creating and managing threads in Java. It provides methods for thread creation, starting, stopping, and joining threads. 2. Java.util.concurrent package. This package provides a high-level framework for implementing concurrent and multi-threaded applications. It includes classes such as threadpool executor, cyclic barrier, semaphore, and concurrent collections A. G. Concurrent hash map, concurrent linked queue for efficient thread-safe operations. 3. Java.util.concurrent.atomic package. This package provides classes for atomic operations on shared variables without explicit synchronization. It includes classes such as atomic integer, atomic long, and atomic reference. 4. Java.util.concurrent.locks package. This package provides advanced lock mechanisms for controlling access to shared resources. It includes classes such as reentrant lock, condition, rewrite lock, and lock support. 5. Java.util.concurrent.executor framework. The executor framework provides a higher-level abstraction for executing tasks in separate threads. It includes interfaces such as executor, executor service, and scheduled executor service, which allow for efficient thread management and task scheduling. 6. Java.util.concurrent.future: the future interface represents the result of an asynchronous computation and provides methods for checking the status and retrieving the result of the computation. 7. Java.util.concurrent.synchronizer classes. These classes provide synchronization primitives for coordinating the control flow of threads. Examples include countdown latch, semaphore, and cyclic barrier. 2. Explain about main thread in Java. In Java, the main thread refers to the thread that is created by the Java Virtual Machine JVM to execute the main method of a Java program. It is the entry point of the program and the thread from which the program starts its execution. In multi-threaded programs, the main thread can create and interact with other threads. It can spawn additional threads to perform tasks concurrently or coordinate the execution of multiple threads. 3. In how many ways can we create threads in Java? 1. Extending the thread class. You can create a thread by extending the thread class and overriding its run method. This approach involves creating a new class that extends thread, implementing the desired logic in the run method, and then creating an instance of the custom thread class to start its execution. Example 2. Implementing the Runnable interface. Another way to create threads is by implementing the Runnable interface. This approach involves creating a class that implements Runnable, defining the thread logic in the run method, and then creating a thread object by passing an instance of the class to its constructor. Example 3. Using lambda expressions. Starting from Java 8, you can use lambda expressions to create threads more concisely. This approach involves creating a runnable object using a lambda expression and passing it to the thread constructor. Example 4. Using executor framework. Java's executor framework provides a high-level abstraction for managing thread execution. You can use classes such as executor service and threadpool executor to create and manage threads in a more controlled and efficient way. Example 4. Explain creating threads by implementing Runnable class. 1. Create a class that implements the Runnable interface. 2. Implement the thread logic within the run method. This method will be executed when the thread is started. 3. Create an instance of the class implementing Runnable. 4. Create a thread object by passing the Runnable instance to its constructor. 5. Start the thread using the start method. 5. Explain creating threads by extending thread class. 1. Create a subclass of the thread class. 2. Implement the thread logic within the run method. This method will be executed when the thread is started. 3. Create an instance of the subclass. 4. Start the thread using the start method inherited from the thread class. 5. The start method internally calls the run method of the subclass, which starts the execution of the thread. 6. Explain the importance of thread scheduler in Java. The thread scheduler is an essential component of Java's multi-threading mechanism. It is responsible for determining the execution order and allocation of CPU time among multiple threads in a Java program. 1. Thread prioritization. The thread scheduler assigns priorities to threads based on factors like thread state, priority settings, and CPU availability. The scheduler ensures that threads with higher priority get more CPU time compared to lower priority threads. This prioritization helps in achieving fairness and responsiveness in thread execution. 2. Context switching. The thread scheduler performs context switching, which is the process of saving the current state of a running thread and restoring the state of another thread to execute. Context switching allows for the interleaved execution of multiple threads, giving an illusion of parallel execution. The thread scheduler handles context switching efficiently to maximize CPU utilization and maintain the execution order of threads. 3. Fairness and preemption. The thread scheduler ensures fairness by providing each thread an equal opportunity to execute, regardless of its priority. However, higher priority threads receive more CPU time. The scheduler also supports thread preemption, where a higher priority thread can interrupt the execution of a lower priority thread to maintain responsiveness and prevent starvation. 4. Synchronization and deadlock prevention. The thread scheduler plays a crucial role in managing synchronization and preventing deadlocks in multi-threaded programs. It ensures that threads waiting for locks or synchronization resources are appropriately scheduled for execution when the resources become available. This coordination helps in avoiding race conditions and ensuring the correct order of execution. 5. System resource management. The thread scheduler helps in managing system resources efficiently. It controls the allocation of CPU time to threads, preventing any single thread from monopolizing the CPU. The scheduler dynamically adjusts the execution order based on CPU availability and thread priorities, optimizing resource utilization. 6. Real-time application support. In real-time applications, where precise timing and responsiveness are critical, the thread scheduler plays a vital role. It allows for the scheduling of real-time threads with guaranteed response times and ensures that they receive priority over non-real-time threads. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until another time, goodbye.